Hello everyone. So today I am going to tell you one important topic, Docker container. So which is an important part of the DevOps technology. So please watch my video till end, and if you have any doubts or comments, so please mention it in a comment section. Good day. So Docker is an open source platform which containing package software into lightweight isolated units called containers, so they can run reliably on any other computers. So the key concepts behind Docker is container, image, Docker engine, and Docker Hub. So container is a running instance of application which is bundled with all its code, libraries, and dependencies. So image. So image is a read-only template, so which is used to build containers. So Docker engine. So it is a core tool that runs and manage containers through a client server systems. And Docker Hub. So it is online registry that is used to download and share pre-made container images. So why Docker matters? So these are the 3 points. It's because of consistency, which stops the work on my machine problem by making sure apps run the same way in testing, development, and production. So second one is efficiency. Containers share the host computer's operating system kernel instead of using a separate guest OS for every application, saving memory and storage space. So another one is portability. So in portability, we can move containers easily between local laptops, cloud servers, and data servers. So Docker solution. So it solves by standardizing the runtime environment. So by bundling the application code with its specific dependencies into a single unit, it always ensures the software runs identically whether it's a developer laptop or a test server or a cloud cluster. So portability, consistency, lightweight, scalability, and efficiency. These are the 5 parameters. So first one is a portability, which runs anywhere in local machine, cloud, and on-prem servers. Consistency. So same behavior in development, testing, and production. So lightweight. So for lightweight, no full OS per app. Containers share the host kernel. Scalability. So it is ideal for microservices and orchestrators like Kubernetes and Docker Swarm. So efficiency. So efficiency which starts in seconds, which uses fewer system resources. So architecture of a Docker and working. So Docker make use of a client server architecture which talks with Docker daemon, which helps in building, running, and distributing the Docker containers. The Docker client runs with the daemon on the same system, or we can connect the Docker client with the Docker daemon remotely. So with the help of REST API over Unix socket or network, Docker client and daemon interact with each other. So here is the diagrammatic representation of Docker architecture. So this diagram which showing the Docker architecture and how the three core components are um, interact to perform basic operations are client, Docker host, and registry. So core components which are containing Docker client, which is Docker CLI. So the interface where uses Docker components, for example, Docker build, Docker pull, and Docker run. So it converts commands into REST API calls sent to the Docker daemon. So Docker host, the machine which is virtual or physical, which is running the Docker background service, is called Docker daemon or dockerd. So Docker daemon, which manages Docker objects like images, containers, networks, and storage volumes. So images, read-only templates used to create containers. For example, Ubuntu and OpenStack. So containers, which are isolated and runnable instances created from Docker images. So another one is a Docker registry, a centralized storage repository for Docker images such as Docker Hub, hosting publicly or private shared images like Ubuntu, OpenStack, and NGINX. So key workflows and data movements are, first one is a Docker build, which is another name as black dashed line. So which tells the Docker daemon on hosts to create a new local image using a Docker file. So another one is a Docker pull, which is the red line. So which requests Docker daemon to download a specific image, for example, Ubuntu, from the registry to Docker hosts local image repository. Another one is a Docker run, which is represented by the blue line. So which instruct the Docker daemon to instantiate and execute a container from a local image. So if the image is not available locally, the daemon automatically contacts registry and pulls the request image down to local storage and then spins up the running container. So these are the components of Docker. So the following are the some of the key components of a Docker. So first one is a Docker engine. So it has a core part of Docker daemon that handles the creation and management of containers. Another one is a Docker file. So it is a file that describes the steps to create an image quickly. Another one is a Docker image. So Docker image is a read-only template that is used for creating containers which containing the application code and dependencies. Another one is a Docker Hub. So it is a cloud-based repository that is used for finding and sharing the container images. So another one is a Docker registry. So it is a storage distribution system for Docker images where you can store the images in both public and private modes. So Docker engine, without the Docker engine, Docker images cannot be built or containers executed. So the client sends Docker commands, Docker build, Docker run, etc. So the daemon receives these commands and performs container operations. The REST API is interface enabling this communication. So in short, the Docker engine is the runtime that makes containerization possible by connecting the Docker client with the daemon to build and manage containers efficiently. So the diagram which is showing the internal low level runtime architecture of a Docker. So the layer breakdown which containing Docker clients which provide the command line interface where Docker issues command like Docker run or Docker stop. So another one is Docker daemon like dockerd. So the Docker daemon serves high level features such as REST API, volume management, and network configuration, image building, authentication. So container, which is high level container runtime, which is responsible for container lifecycle management, which is creating, starting, stopping, pausing, and deleting containers. It receives execution calls from dockerd. So another one is a shim, which is container shim, a lightweight process which is every running container It acts as intermediary between enabling daemonless containers so that if container or the Docker daemon restarts or crashes, the running containers which are remain active and attached standard IO file descriptors are preserved. So RUNC, so it is a low level container runtime which is compliant with the OCI standards. So it interfaces directly with Linux kernel primitives, so which are namely namespaces, C groups, and security profiles. So to instantiate the isolated execution environment for the container. So another one are running containers. So the actual running workload instances managed by runNC are monitored by their respective shim processes. So execution flow is like if user sends a command via Docker client, Docker daemon handles API request, images and networking, then hands execution of to container. So container creates a shim processes for the container. The shim invokes RNUNC to configure kernel primitives and launch the container. So once launched, RUNC exists and leaving the shim to monitor the running container independently of the daemon. So the diagrammatical representation showing the Docker lifecycle workflow. So how source code instructions are transformed into a running container environment. So the core steps are Docker file, build, and Docker image. So Docker file which containing a plain text document containing instructions written in a domain specific language. The Docker daemon executes these commands sequentially from top to bottom to configure the environment. So build step which are executing Docker build which parses the Docker file to compile read-only file system layers. So Docker image, the resulting read-only multi-layered template or blueprint that packages application code, libraries, dependencies, and environment configuration. So the run step which executing the Docker run instantiates the image into a live process. And Docker container which isolated and executable runtime instances created from the image. It adds a thin writable rail on top of the images read-only layers to allow live application execution and the state changes. So Docker image is a file which is made up of multiple layers that contains the instruction to build and run a Docker container. So it acts as an executable package that includes everything need to run an application code, runtime, libraries, environment variables, and configurations. So how it works, like the image defines how a container should be created, which specifies which software components will run and how they are configured. So once an image is run, it becomes a Docker container. So relation to containers, Docker image, which is a blueprint, static, read only. So Docker container, running instance of that image, which is dynamic and executable. So what is Docker Hub? So it is a repository service and it is a cloud-based service where people push their Docker container images and also pull the Docker containers images from the Docker Hub anytime or anywhere via the internet. So it is a vice versa. So repository service, which serves as a global storage hub where users can push or pull container images from anywhere via internet, that is upload or download. So image management, which offers the flexibility to host images in public registers which are accessible to everyone or private registries, so which are restricted to specific users or team like as per applicable. So another one is a collaboration, which simplifies the DevOps workflow by allowing teams to find, reuse, and share standardized environments. So accessibility, which is an open source, freely available tool compatible with all major operating systems. Resource library, which holds millions of official images for popular software like Nginx, Python, Ubuntu, which ensuring a verified starting point for projects. So Docker commands. So while introducing the essentials of a Docker command, so Docker became a powerful software in streamlining the container management process. So it helps in ensuring seamless development and deployment workflows. The following are some of the Docker commands that are used commonly, like 1, 2, 3, 4, 5, 6, like Docker run, Docker pull, Docker ps, Docker stop, Docker start, and Docker login. So Docker run, it used for launching the containers from images with specifying runtime, options, and commands. Docker pull. So it fetches the container images from the container registry like Docker Hub to the local machine. Then Docker PS, it helps in displaying the running containers along with their important information like container ID, image used, and status. So Docker stop, it helps in halting the running containers, gracefully shutting down the process within team. Another one is a Docker start. So it helps in restarting the stopped containers, resuming their operations from the previous state. Docker login, it helps to log in into the Docker registry, enabling the access to private repositories. So Docker has two editions. First one is Community Edition CE, which is free open source and used by individual development teams or open source contributors. So another one is Enterprise Edition, which is paid with security enhancements, certified plugins, images, and enterprise support. Thank you. So if you have any questions or any doubts, so please mention it in a comment section. Thank you.